In Mario 1, we looked at how to implement scrolling to our app. So one of the key features of a side-scrolling platforming game is the ability to scroll our map. In this example, we're going to take a look at controlling the scrolling. So previously it was auto-scrolling, and there are platforming games that are considered auto-scrollers where you don't actually get to manipulate the camera based on your movement. In our game, as we get towards the end, it is going to be a normal scroller in that it follows an avatar. But for right now, we're going to experiment with just moving the camera ourselves with the keyboard controls. And that's really the only explanation I think I'll give for this. I'm going to go over to my main.lua. And actually, really, we're not doing anything with main.lua at all. So I'm just going to run this so we can see what we have. So currently it scrolls automatically. We don't want that behavior. What I want to do is have this be manual. So what I'm going to do, I want to clamp the movement to the width of the map in pixels. And to do this, I'm going to sort of cache some values for the size of the map in pixels. So I'm going to say map width pixels, and I'm going to set that equal to self.mapWidth times self.tilewidth. Same thing here, map height pixels is going to be equal to self.mapHeight times self.tileheight. And so this will keep track of the overall pixel size such that when we're moving our camera, when we're actually moving our cam X and cam Y here, we can clamp that to be, no less than 0, no greater than the sort of upper bound of those values. So I'm going to go down to update, and this is where I want to have this actually happen. Now remember, we have the love.keyboard.isDown function to make this possible. So I'm going to say if love.keyboard.isDown, and we'll just use WASD for this. So W, and then we'll say else if love.keyboard.isDown S, else if love.keyboard.isDown, actually W, we'll do A, S, and else if love.keyboard.isDown D. Cool. So in here we're basically checking up, left, down, and right for the movement. So we'll just say up movement just to keep myself organized here, left movement, and this is down movement and right movement. What we want to do now is basically do what we're doing down here. I'm going to copy that, moving the cam X or cam Y accordingly. I'm just going to copy this in each of these, even though this is currently just moving the camera to the right by setting the scroll speed or setting the cam X going forward. I'm going to go ahead and set, so this is up, so this needs to be cam Y. Down needs to be cam Y as well. So if it is the case that we are pressing up, W, then what I want to do is say that this should be to negative scroll speed for going up. And then if we're going left, then this should be negative scroll speed on X, and then this can be positive scroll speed on Y going down and X going to the right. Let's go ahead and save this and just test this out. So if I move to the right, if I'm pressing D, we do indeed move right. If I press S, we go down. So it looks like we have a little bit of a bug here. So let's go ahead and check this out. I think it's because we are currently not actually setting the translate to the cam Y. Oh, we are setting it to cam Y. Okay. So we're going to say love to translate map.floor negative map cam X plus 0.5, which we are doing floor on. Let's go over to map. And let me just make sure that I'm doing this appropriately. So self.cam_y plus dt. Oh, you know what? Because I have a bug here. I forgot to set this to y. So let's go ahead and make sure both of those are cam y. So I'm going to rerun that. Try it again. I'm moving down, moving up, moving left, moving right, and everything does seem to be smoother. Okay, perfect. Now we haven't taken care of the aspect of actually smoothing out the movement, or clamping the movement, I should say, such that it doesn't go beyond the map edges. So observe one more time. If I run this and I move the map, we do have it sort of allowing us to move left and right. So we're not going to do that. I want it to, or beyond the map edges, I want it to clamp. I want to only show the left edge, but not the sort of cutoff point, and the right edge are flipped. So what I can do is, remember, we have the math.min and math.max functions, which will allow us to say, return the greater or lesser of two numbers accordingly. So in the example of moving up, we essentially want to return the greater of 0 and this value, right? Y being added to negative scroll speed, or dt times negative scroll speed. So if we return the greater of 0 and that amount, it will never get any less than 0. So we can say math.max of 0 and this number. I can do the same thing for moving left, actually. So I can say math.max of 0 and this will prevent both on the y and the x going below 0. And for y, we can return the math.min of the map height of pixels, so self map height pixels of that, and we'll do this for math.min of self.map width of pixels. And actually what we need to do as well is subtract virtual height, because remember, it's relative to the top left corner. So if our camera is relative to the top left corner, but we allow ourselves to go all the way to the end of the map height and width and pixels, then we'll end up actually going all the way past the screen, a whole screen size past the border. So we want to subtract virtual height and virtual width from that to account for the screen's offset. So we'll say virtual width in this case. Run that. Now if I move the camera, I can't actually move left here. It's preventing me, which is perfect. That's the exact behavior I want. And if I try to move right, this is as far as it'll let me go right. And if I move down, eventually I'm going to hit the bottom of all the brick walls, which will be more or less the screenshot that we saw in the prior example. And if I move up as well, eventually I won't be able to move anymore. So that's it in terms of getting the ability to control the movement of the screen. In the next update, we're going to look at something I think a little more visually interesting. We're going to get into procedural generation with the ProcGen update, where we actually see how to create something beyond just a flat sort of grid of bricks and start adding columns and spaces and bushes and blocks and clouds and so on and so forth. So we'll see you then in Mario 3.